All right, so now we're going to move on to video 2 for the scientific method cheat sheet. You should have already finished the first one where we went all the way through hypothesis. Now we're going to talk about experiment. So go ahead and go to markup and find your highlighter, whatever color you want to use. And we'll get started. So experiment, this is the fun yet tedious part of the scientific method. The experiment is when you perform the test, but there's a lot more to it than that. In addition to the actual testing of the hypothesis, your experiment also includes the materials, the procedure, the variables, and the data. So let's highlight materials. This is straightforward. Write down in a bulleted list, highlight bulleted, everything that you'll be using in your experiment. Make sure you list as a bullet because 1, it's easy to read, and 2, it's easy to check to make sure you have the needed items if you want to reproduce the experiment later. So do not ever write in a paragraph form for materials. That's boring. If you're looking for an experiment to do for the science fair and you're on Google and you see a materials list that is like 25 sentences long in one big jumbled paragraph, I don't know about you, but I'm not going to read that. So you want it to be easy to read, simple, bulleted, so I can quickly scan and see, okay, beakers, I got that. Water, I got that. $1 million, I don't have that. I can't do this experiment. So a bulleted list for the materials. Next, procedure. Oops. This is exactly step by step what you will be doing in your experiment. Make sure this is written as a numbered list. That is very important. Again, this is easy to follow and it's easy to make sure you're going exactly in the correct order. Make sure that you list every step. Let's highlight that whole sentence. That's very important. Pretend that a 5th grader is going to do the experiment based on how you've written it. If they couldn't follow it, then it isn't a good procedure. All right, so step by step, exactly in order. Write that out numbered 1, 2, 3, 4, and so on. Do not write the procedure in paragraph form. That is too much. I'm not going to read the procedure if it's in paragraph form. Also, it's really easy to get distracted. So if you are reading something that's jumbled up into, a 28 sentence paragraph and you have to look away for a minute, or if you get a text or your mom's yelling at you or something. I don't know about you, but I would get distracted. I would not be able to come right back to that exact point that I was at. And you can miss a step, and that is never, ever good. Also, make sure that you list every step. If you, like, that seems like duh, but there's some things that you may not think about. Like if you rinse out a beaker. If you put substance A in the beaker, pour it into test tube 1, rinse out the beaker, then pour in substance 2, make sure you put rinse out the beaker as a step. Because if you don't, and you rinse out your beaker whenever you do the experiment, but you don't write in your procedure, step 5, rinse out beaker. Then somebody who's reproducing the experiment, who's doing it themselves, based on what you've written, they may not rinse it out and maybe a big explosion happens. I know when you think science experiment, for some reason, everybody thinks like big explosion, but that's usually not good. So make sure you put every single step, everything that you do, even if it seems like mundane or obvious. Because again, the last thing I put here is you're going to pretend that you're writing it for a 5th grader. Okay, so that 5th grader is not going to be in this class. They're going to have no clue what's going on. They're somebody who's not in the room. They've not seen the experiment happen. So they don't know what they're doing or what's supposed to happen. So make sure you put every single step. All right, next, variables. Here's where it gets a little complicated. You've probably not talked about these. If you have, it's not been very in-depth. We're not going to talk about it very in-depth either, but it's something that you need to have heard of because as we go along, as you have me in 6th grade, 7th grade, 8th grade, we're going to talk more about variables each year. So the variable is what can be changed in an experiment. There are 2 important variables that you must note, independent and dependent. The independent variable, let's highlight that, is the variable that is changed or tested. For example, if you're measuring the height of a plant based on the amount of water given, then the amount of water given is the independent variable. Let's highlight that, the amount of water given. And I'll tell you why in a minute. The way that I remember this is independent means I control. Very important. Only change or test one variable at a time. If you test 2 or more at once, you won't be able to tell for certain what caused the change. For example, if I give a plant more water and more fertilizer and more sun, how can I tell for sure what caused the plant to grow more? So independent is what is changed or what is tested. So I'm in control of that. So the example, if we have a bunch of plants and we're going to measure the height of a plant based on how much water I give it, what I do is I give it water. So that is the independent variable. I control how much water is given to the plant. So we only change or test one variable at a time because, like I said there, if we do a million things, we're not going to be able to tell for sure what caused the change that we saw. And if you remember from the last video, our hypothesis, we said it needed to be measurable. So we can't really measure the effect of one certain thing on plant height. If we change the amount of water, if we change fertilizer, if we change the location, all that stuff. So for independent variable, it's what I control, what I do in the experiment. I'm giving water to the plant, and we should only do one thing at a time. Next is the dependent variable. That is what is measured at the end of the experiment. For example, if you're measuring the height of a plant based on the amount of water given, then the height of the plant is the dependent variable. The way that I remember this is dependent depends on independent, or what I do. So the dependent variable is the results. It's what's measured. So if I am figuring out how tall a plant grows based on the amount of water I give it at the end of a week, then the height of the plant is what I test. That's my results. So that's the dependent variable. And the dependent variable depends on whatever I do. So the height of the plant, the dependent variable, depends on how much water I give it, because that's what I'm testing. I know that's confusing. I don't expect you to know that with 100% clarity after watching this video. Don't freak out, right? Another component is the constant. The constants in an experiment are the things that stay the same for every test. For example, think back to the plant example again. I would use the same type of plant, the same type of potting soil, the same pot, the same amount of fertilizer, and so on. These would be the constants. So let's highlight that. So constant is just like in math, like 2 is a constant, 2 is always 2. That's just like, it's the same thing in science. The constant is whatever we keep the same. So if we're going to test how much water or how much a plant grows based on the amount of water we give it, we may have 5 plants set up throughout the room. To know for sure that the water is the only thing affecting the height of the plant, then we need to make sure we're using the same pot, the same potting soil, the same type of plant. They're in generally the same location, all that good stuff. The only thing, so those will be constants, they're the same. The only thing we would change is the independent variable, what we're in control of, what we're worried about, which is the amount of water. All right. Next is data, or data. I don't care what you say. The data is all the stuff that happens during the actual experiment. When you watch the experiment take place, you should jot down anything you see happening. That is so important. For example, a liquid may start to fizz, the plant may have grown 3 inches after a week, or the substance may have changed color. Let's highlight those. Those are really good examples of data that you may see. Data is taken throughout the experiment. That's so important. And as a result, your data may look really scattered. That's fine. Once all data has been collected, you can always start a new page and organize your data better. Just make sure that your data or your information is easy to read once the experiment is completed. So data is just the stuff that happens. So anything that happens while you're doing an experiment, write it down. You will have, when we get back to class, you will have a notebook specifically for labs, for lab data. So you'll just jot stuff down that happens. That's really important. Make sure it's not chicken scratch. Make sure you can go back later once you've completed the lab and make sense of it. Because if you have a bunch of just stuff jumbled, written out, and you don't even know what it says, I'm probably not going to know what it says either. So we need to be able to make sense of all that stuff that happens. So you can have it all scattered out, written upside down, wherever on your paper, as long as you can read it and make it logical later. And this is so important. Data is taken throughout the experiment. It's not the stuff at the end. That's your results. That's your conclusion. Your data is all the stuff. So it happens all throughout the experiment. You're going to take down some notes about it. In most of the labs that we do in class, you will be given a chart to organize your data from the beginning. This is also an acceptable way to collect data. Data can be written statements, charts, graphs, diagrams, pictures, and so on. So let's highlight that because that's important too. Data is not just words. It could be pictures. You can even, like, if you're doing, like way back in the first video, we talked about a good question or a problem may be, do seeds need light to sprout? So your data could be pictures after every single day of that plant. So anything that's happening during the experiment, however you can take that information down, that counts as data. All right, so that is everything for the second video. You can go back and make sure that you have everything highlighted that should be, and we will watch one more tomorrow and finish this up. Thank you guys.